Hello everyone, this is Pranav, and today we again have a pretty nice problem. We are back with CMI, Chennai Mathematical Institute, and today we are going to learn how to solve an exponential equation. Now, this might seem simple, but there are quite a few silly mistakes that a lot of people do, and we're just going to see how we can avoid that to score full marks. It's an easy question, but at the same time, we need to keep in mind that we do not make any silly mistakes. Alright, so let's get started. This is the problem number 2 from the part B of the CMI entrance exam in 2018. CMI is, as you may know, a very reputed mathematical institute in India, the Chennai Mathematical Institute. And in this video, we're going to learn how to solve an exponential equation. And basically, the second part of it would be to simplify an algebraic expression. And after that, we're going to look at some book suggestions for ISI CMI. And then we have, at the end, a similar but challenging problem. So let's begin.
This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
So this was the problem, and it had two parts. It had two subparts, basically A and B. And in the first subpart, they're asking us to find all real solutions to the equation that's given over here. Now, we can see that on the right hand side, we have 1. And whenever really we have a raised to the power b is equal to 1, this is only certain set of solutions, right? So the first set may be where a is 1 and b can be really any real number k. Right? 1 raised to the power anything is obviously 1. The second case might be when a is anything but b is 0. And obviously k raised to the power 0 is obviously 1. But a lot of people forget over here that k cannot be 0. Because obviously 0 raised to the power 0 is indeterminate quantity. Right? So k cannot be 0 for this subcase. And for this case, and for the third case, well, this a lot of people actually forget this. Minus 1 raised to the power even number is also 1, right? So this is kind of a trick that a lot of people sometimes forget, right? So a needs to be minus 1 and b needs to be an even number. So b needs to be 2k for some real number k, right? So these are the three cases that we have. Let's just evaluate them one by one. So you have the case 1, and in that we have a1, so x square minus 2x, that was a is equal to 1. Or in other words, x square minus 2x minus 1 is equal to 0. And really, we can try and solve this using the quadratic formula. So x will be minus b plus or minus square root of b square minus 4 into a into c over 2a. So when you just simplify this, this will be 2 plus or minus 2 root 2 divided by 2. So that simplifies to x equal to 1 plus or minus root 2. Right? So we get two solutions for this case. Now we have case number 2. And let me just change my color. For case number 2, we had anything raised to the power 0, provided that anything is non-zero, right? So x squared plus x minus 6 needs to be 0, and you can just easily factorize this. X plus 3 x minus 2 is equal to 0. So we get x equals to minus 3 and 2, but we had the case that a cannot be 0, right? So x squared minus 2x cannot be 0. So x squared minus 2x cannot be 0. Therefore, x cannot be 0, 2. So this 2 is eliminated. So the only solution for this case we have is x is minus 3. That's the solution you get for this case, right? And we had two solutions earlier. Now let's move on to case number 3. And here we had minus 1 raised to the power even, right? Minus 1 raised to an even power. So we have x square minus 2x is equal to minus 1. Or in other words, x square minus 2x plus 1 is equal to 0. And this is, as you very well might know, x minus 1 whole square is equal to 0. So therefore, x equals to 1. Now we just plug in x equals to 1 into the exponent and see if it just satisfies. The exponent was x squared plus x minus 6. So this needs to be an even number at x equals to 1. So that gives us 1 plus 1 minus 6, which is minus 4, which is even. So minus 1 raised to the power minus 4 would be 1. And therefore, x equals to 1 is also a valid solution. So we had 4 solutions. X equals to 1. We had x equals to minus 3. And we had these two solutions, 1 plus or minus root 2. And all 4 solutions are valid. So we have 4 solutions to this question. Alright. Now moving on to part B. In part B, we have to simplify this expression. Okay, so let me just write that again over here. It is, let's name that expression as t. Okay, it's the cube root of, I believe it was 6 root 3 minus 10. Let me just see. Yeah, 6 root 3 plus 10 and then cube root of 6 root 3 minus 10. Okay, perfect. We had minus over here, cube root of 6 root 3 minus 10, right? Now how are we going to solve this? Well, obviously the easiest expression is just to cube it. We have a cube root on both sides. So like whenever in such type of questions, whenever you have just have a cube root on both sides, on one side you can just cube it so that you can get rid of it, because we really like working without radicals, right? This is just a minus b whole cube, which gives us a cube minus b cube minus 3ab. So that would be the cube root of 6 root 3 plus 10 times 6 root 3 minus 10, and a minus b will simply be t, right? So we get t cube is equal to 6 root 3 plus 10 minus 6 root 3 plus 10 minus 3 times the cube root of 108 minus 100, which is 8, and we have t multiplied over here. Now that's great, as we know that the cube root of 8 is 2. So this becomes t square plus t cube plus 60 is equal to 20. And we can really see that this has a rather easy solution. So t is equal to 2 easily satisfies this, as 2 cube is 8 and 6 is 12. So t is equal to 2 is a valid solution. Now how do we know that this is the only solution? Well, we just use the factor theorem, and once you use the factor theorem, you can easily see that this given expression has no real roots other than t is equal to 2, right? So the given expression is 2, and that is our answer for this part. So yeah, it was pretty simple, relatively speaking, but I hope you did not make any silly mistakes while solving this. Okay, so moving on to certain book suggestions for the CMI, we have Challenges and Thrills of Pre-College Mathematics, we have Mathematical Circles, a Russian Experience, we have an Excursion Mathematics, we also have a Test of Mathematics at the 10+2 level, and we of course have Elementary Number Theory by David Burton. Okay then, we have a similar but challenging problem. It's also an exponential equation. I want you to find out all values of x that satisfy this given equation. Right? 8 raised to power x minus 2 raised to power x divided by 6 raised to power x minus 3 raised to power x is equal to 2. And as always, if you make any progress on it, or if you are able to solve this question, please let me know in the comment section, and I'll be sure to respond to it. Until then, bye bye. Thank you very much.
Chinta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit chinta.com.